Hi everybody, this is Mr. Kacha. Today we're going to talk about properties of parallelograms. This is page 21 in your notes. We're going to discuss these properties through construction. So I'm going to draw construction on this piece of paper, and your job is to take and fill in those notes in your notes packet. So we're going to start with a parallelogram. We know the definition of a parallelogram is that a quadrilateral with two sets of parallel lines. So I'm going to start with drawing one set of parallel lines, and I'm just going to take my ruler and start constructing a set of parallel lines. Again, I know these are parallel because the distance between those two lines is the exact same. In this case, it's just the distance between the two edges of the ruler. Similarly, I'm going to draw another two parallel lines, just turning my ruler vertical. And I have a quadrilateral with two sets of parallel lines. Again, we constructed this. So here's my parallelogram. Now, we're going to look at the properties of parallelograms. And we're going to start with angles. So let's take a look at angles first. I don't know the measure of any of them, but since we constructed this, I can grab my protractor using the tools that we have available, just measure one of the angles. I measured this angle, it's about 95 degrees. So I know this angle is 95 degrees. Now, since we have parallel lines and a transversal, again, remember this from Unit 2, there exists a bunch of relationships. Same side interior, same side exterior, alternate interior, alternate exterior. We're going to start at looking at this angle and this angle. Those two angles are called consecutive angles. I know the relationship between those two angles, if we're just looking at two parallel lines and a transversal, is that they're same side interior angles. And we know in same side interior angles are 180 degrees. They're supplementary. So if this angle is 95, this angle has to be 85. Now, that's just something we calculated. Let's make sure. Take our protractor again, measure the angle, and check that out. That's about 85. Now, that's these two parallel lines. Now let's take a look at these two parallel lines and this transversal. So we can see that those two angles are also same side interior angles. That must mean that this is 95 degrees. Same thing with these two angles. That must mean that if it's 95 degrees, this is same side interior angle, that's the relationship, then this has to be 85 degrees. Now, since we look at this, we can start coming up with some properties. The one that we talked about already is consecutive angles. We know consecutive angles are supplementary. Now, we can also look at opposite angles. These are exact opposite from each other, and we notice through doing some calculations that they end up being congruent. Again, we just constructed this using a ruler. With a protractor, we can see that opposite angles are congruent. Another property that we can just come up with through construction. Now that we looked at angles, we can start looking at sides. Let's take a measure of one of these sides. This is about 3.1 centimeters. Let's see what the other side ends up being. It's also exactly 3.1 centimeters. So we know these two set of opposite sides are congruent. What about these two? This is about 3.2 centimeters. And let's see what this one ends up being. This one's also about 3.2 centimeters. So now we can conclude that in a parallelogram, opposite sides are congruent. That's another property. So now we have three properties. There's only one thing we haven't looked at so far in this, and that's diagonals. Well, let's draw in our diagonals and see what we notice. There's one diagonal, and there is another diagonal. Now, let's take a measure of our diagonals. This diagonal is about 4.1 centimeters, about 4 it looks like. This diagonal is 4 centimeters, and this diagonal is about 4.5 centimeters. Well, that doesn't say anything. let's take a look at it again. Look at the diagonals again. Well, I noticed that when I line this up, this diagonal, this part of the diagonal is the exact same as this part. They're each 2 centimeters. And, well, I know now that this diagonal is bisecting this diagonal. Well, let's take a look at the other diagonal. Let's see if we see anything over there. That diagonal is about 2.25, which is half of 4.5. So we can notice that both of these diagonals are being bisected by each other. So that's our last property, that diagonals are bisectors of each other. So we have these properties of parallelograms. Okay, good luck filling in your, go ahead and fill in your notes on page 21, and we will do some practice problems tomorrow in class. Have a good day.